Hi guys, I'm Debbie and this is LM Squares, and today we'll be talking about the third method of differentiation, which is the chain rule. Okay, the chain rule is used when we have a number of terms that are either adding or subtracting and also raised to a power. When we have a number of terms that are either adding or subtracting and also raised to a power. Let's take a look at what I have here. I have y equals 5 plus x raised to power 2. 5 is adding x, okay, and also raised to a power. Okay, so the concept of chain rule is dy over dx equals dy over du times du over dx. This is simply the concept of our chain rule. Dy over dx equals dy over du times du over dx. All right, let's say I have y equals x raised to power 2 here. Using the general method, dy over dx is giving me 2x. I hope you know how I got my 2x. 2 times x raised to power 1, which is giving me 2x. Okay, coming back to what we have, I have y equals 5 plus x raised to power 2. 5 plus x raised to power 2, and yeah, this is different from y equals x raised to power 2. Y x raised to power 2 is simpler to 5 plus x raised to power 2. We're having a sum of terms up here, which is 5 plus x raised to power 2. Okay, so let's use the chain rule, or let's see how we can introduce the chain rule here. So y equals 5 plus x raised to power 2. Let's our u be what we have in the bracket here, which is 5 plus x. Okay, let's use 5 plus x to represent u. So let our u equals 5 plus x. I hope I get it. This is very simple. Let u equals 5 plus x. For example, if we were to differentiate y, let's say we have y equals x. If we are to differentiate, we'll say dy over dx, right? Yeah, so that's the same thing we are saying here too. That's the same thing we are going to be doing here. Expressing u in terms of x, will be having du over dx. Okay, so u equals 5 plus x, so I'm having du over dx equals, yeah, let's differentiate 5. 5 is a constant. Differentiating a constant gives me 0. Okay, so I'm writing 0 here. 0 plus, now differentiating x using the general method, x is the same thing as x raised to power 1. I hope you know this. X raised to power 1. Okay, 1 times x raised to power 1 minus 1 is giving me 1 times x raised to power 0. 1 times 1 giving me 1. Okay, 0 plus 1 finally is giving me 1. So my du over dx equals 1. My du over dx is giving me 1. All right, y equals 5 plus x raised to power 2. That's all we have in our question. Y equals 5 plus x raised to power 2. Don't forget, I said our u is 5 plus x. Okay, so we're having a square up here. So let's say our 5 plus x is represented as u. All right, y equals u raised to power 2. Yeah, our 5 plus x is u. So coming back here, y equals u raised to power 2. I hope I'm getting this. So let's differentiate now. Let's differentiate y in respect to u. We'll be having dy du. I hope you get that. Dy over du. So y equals u raised to power 2. Dy du now will be giving me 2u. How did I get my 2u? I'm using the general method to differentiate u raised to power 2. 2 times u raised to power 2 minus 1. That's 2 times u raised to power 1. That's 2u. I hope you get that. 2u. All right, now let's use the chain rule. Let's use the chain rule. Dy over dx equals dy over du times du over dx. If you remember, that's the concept of the chain rule. All right, now my dy over du, we just solved that now and it gave us 2u. So I'm substituting equals 2u. Dy over du is giving me 2u, and if you remember, when we solved our du over dx, it gave us 1. So I'm just simply substituting 2u times 1. 2u times 1. Okay, so my dy over dx is giving me 2u. It's giving me 2u because 2u times 1 is definitely giving me 2u. I hope you get this. All right, let's continue. We're having u here. We are having u here, and we are differentiating y and x. Are you following me? So we can't have, it's not possible for us to differentiate and have different terms in respect to each other. Okay, we're having y x u here. It's not possible. So let's just express u back in terms of x. It is possible. Yeah, don't forget I said our u equals 5 plus x. So I'm having a term in x which is also representing u. I hope you get this. Yeah, so the y over the x is simply giving me, don't forget I said 2u here, 2u, so our u is 5 plus x. So simply put it, I'll be having 2 into 5 plus x, 2 into 5 plus x, using the chain rule. I hope you understand this. This is simply the concept of chain rule. Alright, so we've expressed u back in terms of x. You know, we're differentiating y and x. Alright, so we cannot be having a different term here, which is u, so we had to express u back in terms of x. I hope we get this. Now we have the y over the x equals 2 into 5 plus x, 2 into 5 plus x. So this is simply the concept of the chain rule differentiation method. And now, if you've not subscribed to my channel, make sure you do so. Like, share and comment. Thank you.